Hello again, this is Michael Hicks, and we're going to move into a broader discussion of some statistical concepts in this class. But I'm going to begin by introducing you to some data sources, places where you can get data to do the things that we would want to do in any sort of economics or business class involving data. As an economist, I rely on economic data produced either by federal government, the Federal Reserve, or some other source that standardizes and spends a lot of money on gathering data and information. As a business leader or a data analyst with business, you're going to be looking at more sources. And we'll talk a little bit about that, but the classes that you'll have down the road that look at different sorts of software packages will tell you which ones are more amenable to different types of data analytical processes. And so what I want to start with is walk you through some sources of data. And I begin by showing you my computer screen, which has the website for the Center for Business and Economic Research at Ball State. And this is where I work. And one of the missions of the center is to maintain data sources and links to data sources for faculty and staff. So you can come to this main page here and navigate to the menu and go to, there's several things. There's things about us, things about what we do, our research studies often, which contain citations and study, and then our data center. If you come to our data center, you have a number of things. We have several types of data that we've curated for clients and communities. There's a grant writers toolbox, and this covers community grant writers in Indiana. We did this to help them write grants to remediate brownfields. We have a community asset inventory ranking, which ranks each county in Indiana on several different data elements. You have to sign in to to use some of the features on this, but we actually have ways to do analysis. I'll just do a Delaware County. Here's the data that's available, and you can download that spreadsheet, very easily. On a CVS. This is population data. And then we have more curated data. Dependency ratios are the number of non-working folks relative to those that are working. This gives you a sort of sense of how many older and younger people there are. And I'm going to go through almost an infinite amount of data here. We have let me close out of that. We have a community asset inventory and rankings, which again grades each county. I'll go to the county I'm in. To sort of gives A's through F's based on how well it's doing on a number of different measures. And we also have a housing value barometer here, which gives the value of homes in surrounding counties and some information about it. There are other data here. Community Readiness Initiative is really for smaller communities, so this is something that's better tailored to not to a student but to a community. This is an annual manufacturing report card that our center gets a lot of information about. These are the products that we write, and then the spreadsheets that we have available for the work itself. So this gives us the different county rankings, and I'll click out of that. Navigating back to our data center, we have an impact calculator. We have economic indicators that are powered by a third-party data source. We pick the data, they run it. We have a tax savings calculator. If you're in Illinois and you want to know, how much more expensive it would be to move or less expensive to move from your county in Illinois to Indiana, you can do this. And then we have county profiles that give a great deal of information about that. And then again, a significant amount of archived information. We also have restricted databases that are used for Miller College and University researchers. So these are all things that are subscriptions for the college. So you can either access them directly from a a on-campus site. You can log in some instances, or you can VPN directly. If you VPN through the university, they'll recognize your .edu information. Some of these classes will be taught, later classes in accounting, maybe use audit analytics or global insight. Finance may use Bloomberg. Marketing may use Mintel or Nielsen. And management may use the Wharton Research Data Services. So these are places where you can actually access their data, but you have to register. I don't use most of these, so I'm not registered. The university also sustains a number of subscriptions. These are business-focused databases, so these are places you can go directly through the university to access if you're working on a VPN. And then there are data and business reports. Some of these are now gone. American Fact Finder just went away, so we'll have to look at. And so some of these are very good for doing firm analysis or business analysis, but there are a wide variety of these data sources. Those are going to be things you learn about in the classes where their data are available. They're maintained through my center's website. If you're doing research in economics or elsewhere, we've created a data source that has just a spreadsheet of data, and I'll download this spreadsheet real quick. This is a data guide that we've created that provide information about a wide variety of data sources around the country. So these are data with links directly to them. The acronyms over here tell you what are the sources of these data, AAHRP, etc. Fairvo data project at Harvard, and these come on and offline, but they're a pretty robust set of data sources. So if you're interested, for example, and you want to look at the consumer price index, right, you can click on this site and it will drive you immediately to I'm sorry, I'm getting some scratchy feedback here. Drive you immediately back to the original database. And so here you can go to the data for inflation and prices. You can download either tables here of news releases. You can look at different series. These are urban wage and clerical workers, all urban consumers, average price data, industry-specific price indices. These are the producer price indices. They used to be called the wholesale price index. So they will tell you specifically how changes are occurring at individual industries. So let's see, new industrial building collection, what do they say? Go to their online source to see what the index looks like. And you can see the source of base data from the Bureau of Labor Statistics. So if you're looking at getting the original data, if you don't understand the original data, because I'm going to show you other sources that are easier than this is the place to go. Most of the other data sources will have some link back to these. So this is a good way to approach the data, because you'll want to understand, what this means. But this is in a tabular form. You can download the data and deal with it yourself. And it shows the preliminary data, which may not be always apparent in the secondary source. So I'm going to go back to the spreadsheet. Right. And gas tax rates, let's just go to the U.S. Department of Transportation, Federal Highway Administration, and you can look at motor fuel taxes by state each year during those time frames. So you can now state tax rates on motor fuels. And then immediately you get, these are state taxes on average, not individual taxes, and then diesel, and then here's the state motor fuel. Sorry, this is the gasoline tax for each state, diesel fuel, and then nothing. All right, so these will be interesting later on because we're going to do some projects using these data that I think these are sources that are interesting if you're interested in these in transportation. There's something in this data set that should interest each of you, and so that's one of the all right, there we go. So Indiana local government data, municipal government data, U.S. voting database, right? GDP data, healthcare data, poverty data, and it gives secondary sources like the Kaiser Family Foundation insurance data, international economic data, and then sources usually to that, and then fairly broad list of data. So each one of these represents typically several dozen, and we have 135, 136 data sources on this website. So I think that's a pretty good tool for you to consider looking for data at. Most of the data, I'm going to go back to this, a big portion of this data in these data guides are going to be central sources to cross-sectional data. So we could look at, let's pick across retail sales. No, let's look at taxes here. And so we'll be able to have, this is Stats Indiana, this is run by you. And so, we can look at population here. So this will give us Indiana counties. These are the decennial census. So this is a cross-sectional data for Indiana county populations for each year and time series over time. So this is a time series cross-sectional data source. And these are the types of things that we could, quickly examine using some of the statistical tools that we'll talk about as time goes on. But one of the easiest places to get data is this website, the Federal Reserve Economic Data site. It's called FRED. Type in FRED economics, and you'll get this data. And there are, 60,000 different data sources, over 1 million data sources, they say, here in this, across this. There are a lot of things that you can do. You make graphics. You can choose the time frame that you're looking at. You can include business cycles, which they do here. It gives you related content, initial claims for most recent ones, data, a blog about what these claims data say that are good cited homework. If you're talking about one of these things, one of the economists at the Federal Reserve, has worked through explaining what this is so that it's clear to data users at this point. And then other ways where you might want to look at ways of looking at this. These are FRED blogs. This is an important service by the Federal Reserve system. And so you can choose all sorts of different data sets here. We'll look at gross domestic product. Right, and this gives us GDP from 1947 in the U.S. quarterly to now. There are total public debt relative to GDP. So there's millions of transformations. And you can see over here, just in the GDP tag, there are 74,000 different ones, all the way down to GDP just for the Tennessee Valley Authority area. That's the surplus there. It's a measurement, right? And so that's it. These are our data sources that it's good for you to think through using on occasion. There are other data aggregators, but this one is is so commonly used that if you're on Twitter, if you're on Facebook, if you're reading economic accounts there, you'll see this information appear in those sources. So let's go to a data source that I download. This is that initial claims data set. And I'm going to show you, there are a number of ways to do this. There are add-ons to Excel, but most of you are not going to have those. You're just going to have a basic piece of Excel software available for you. And there are a number of ways that we would wish to display this data that would be meaningful. Some of them are graphical, as the website illustrated before. And a graph, the website graph for the Fred data set is a very straightforward, let's go back to it, initial claims, right? It's a very straightforward line graph with recessions marking it. So the recession we're in now, the 2008 through 2009, 2007 through 2009 recession, 2001, 91, 92, or 90, 91, I'm sorry, 82, all the way back to this data series weekly that started in 1967. The monthly initial claims go all the way back to 1945, or maybe even earlier, after the UI system was first made available. And so we can display things graphically, but sometimes graphical depictions aren't really that helpful. Sometimes we want to look at area charts because we have a different line that we wish to compare. And those sorts of choices are largely designed to be appealing to the eye and to convey information with the most spare amount of noise, right? You want the signal to noise ratio, an idea that we'll talk about in this class a lot, to be very high. So we want a lot of information, not a lot of noise here. So we have, in this graphics, pretty good, we have initial weekly claims, we have the number of claims and actual values on the vertical axis, we have every 5 years on the horizontal axis with the graphic, with a depiction of business cycles as well in the shaded areas. So this is a very good piece of the display of the visual display of quantitative information. We might want to change this to show periods where we were below or above average. We may want to just highlight early parts of recessions. There are a number of different ways in which we could depict this information that would be useful to us. Sometimes it's cumulative job losses. So these are, important ways that you can do this. And my guidance for this is to look at a lot of graphics that you see in newspapers. The TV is the worst place to see graphics. You almost never see good graphics in the news. And just to think sort of critically about how much information is being conveyed, how long do I need this data to be? So for example, I'm pretty sure we could convey the magnitude of what we're facing now by going just back to, say, 2007, right? Because 2007 was the start of the Great Recession. So, if we really want to see what's happening in terms of initial claims right now, we can go back to then. So at the peak of the worst month in the Great Recession, that was March of 2009, right? We were well below where we were last month and where we were last week and where we're going to be Thursday this week when the new number are related. Sometimes multiple graphics need to be displayed at the same time. We are essentially have a 0-1 here, shaded recessions. Maybe cumulative job losses as well would be, because these are initial claims, but the continued or cumulative change would show how many Americans who are covered by the unemployment insurance fund are actually unemployed at any given time. So that might be an interesting tool as well. And so as we think about that, a lot of that's going to be outside the economics realm. So I'm just going to hint back to it and not teach it because it's not really statistics.
it's not really economics, it's how you communicate these things. So if you're thinking about what to pick up in an MBA program, it ought to be, in addition to understanding economic theory, the statistical work that you do, the ideas surrounding accounting, finance, management, marketing, you also need to be able to communicate this well. And so building a portfolio of graphics that you know how to use for the information you're trying to display, I think is very powerful. And one thing that I hope our graduates do a fairly good job at. So getting to the core of this, I'm just going to go to this material and say, so we have data on this graphic that is, there are 2,808 or 2,806 different observations. So we may be interested in what are called moments in statistics. So you know what these are. You haven't heard them called moments. The first moment is the mean, right? And moments describe data in numeric terms in ways that are relate back to the base data themselves. The first moment is the mean. So I'm just going to use the software, the base software in the average. The mean is often referred to as the average, right? It's the most common way of describing data over time is just the average, right? So we care about the average test scores of a school. We care about the average height, maybe or weight of a defensive line. And in this case, we care about the average number of new or initial claims each week. That's one way of describing the data. And that is often referred to as average, but there are really three types of average. There's the mean, right, the first moment. There's also the median, and the median is the value that is midway between the highest and lowest. Right, so the median is that central point. Both the mean and the median are measures of central tendency. And then the third type of average is the mode, or the most frequent type. In some types of data, the mode isn't very helpful, right? So the mode here on what is essentially a continuous time series variable is not going to tell you a whole lot. It's going to be fairly close to the mean, we suppose. A different instance might be where the mean, the median, and the mode tell us a great deal. Might be in student loans, right? So in college loans, in college debt, we know the mean is about, we call that the average, is what, $27,000 per student at the culmination of a bachelor's degree completed. So that's what the average student has using the mean as accrued. However, the median, where half of students are lower and half are higher, is closer to $10,000. So about half of students have $10,000 or less in student debt. And so what that tells us is that there is skewness in the data, there are a number of people whose debts are so high that if the median and the mean are the same, you have a normal distribution typically. But in this case, you don't. You have a number of very high debt driving the average or the mean above the average of the median. And interestingly, the modal, or the most common student loan debt, is zero. About a third or more of students graduate college with no debt. And so, and there's an instance where the mode doesn't tell us a lot about the distribution, but it tells us that there are a number of, that average student debt by itself maybe is not representative of the typical student experience. For this data, we care about the first moment because it gives us a benchmark of what to compare against. This is what you might expect a state government to prepare for, the average weekly claims. The second measure is the variance, right? The variance. And we often measure the standard deviation first. So that's the standard deviation of the entire population, not the sample. When you make these calculations later on in the statistics class, you'll see the difference in the two. Whenever you can do a population standard deviation, you would like to do that. Here, the population standard deviation is 266,661. The variance is the square of the standard deviation, right? So the variance is the second moment of the this value. Let me just put it in terms. So when you compare the standard deviation to the, so what I can do is just move that over. So this is I'm going to do the average. And not square it. So that's that average. And so the mean, and so the standard deviation is, 150 times the mean. And so this shows that this is a volatile data series over time. It also gives you a sense of what, when you're thinking about the data, that just reporting a mean may not be that useful. And for management purposes, if you were a manager and you were preparing your staff to deal with the mean, if the standard deviation was 10% of the mean instead of several hundred times the mean, then maybe that would be a good management plan. And so we'll get, when we do hypothesis testing, why we care about this, because values that lie close to the mean are oftentimes in a sample are viewed as representative samples. Samples that are drawn that don't lie near the mean are not. And so this is the average, and this is a measure of central tendency, right? How close do the observations fall from one another? The two others that we care about are going to be skewness, and skewness represents the asymmetry of the distribution of data. So the distribution of data, if you think about a normal distribution as a bell curve, and all of you have read or heard about a bell curve, a normal distribution has a mean of 0, a standard deviation that relative to the mean that is standardized, and that distribution is the one that is assumed throughout most statistical work, but we know it's not really the case. We assume it and hope that our statistics are not made, our statistical analysis is not damaged by the assumptions of this. And the reason is that the failure of there to be this normal distribution, if in some circumstances, can bias your results. So give you a bad statistical estimate. And so skewness tells you if the data are really skewed towards 0 or really high. So for example, the skewness, which would be the cube of the mean, right, would be a measure of how distributed this data series is. And you can see it's very rightward skewed. If it was negative, it would be leftward skewed, right? So we're probably in a outside what you're going to run into for the most part, but it's important to understand that those higher moments also matter. And then finally, there's something called kurtosis. right? So kurtosis is just measures how fat the tails are, right? So if something's skewed and it's got a fat tail, the kurtosis will give you information about that. And so when you get doing advanced statistical work, these things matter. In forecasting, they don't typically matter in terms of building the statistical models, and in the work that you do in the MBA, the skewness or kurtosis are going to be somewhat important, but you're going to be much more concerned with mean, the standard deviation, and its square of the standard deviation, which is the variance. And so what I've done in this, 25 minutes or so, is just give you some source access and gone through the summary statistics that we see. I will tell you that in many published research studies, almost everyone that I do, we report the summary statistics. It's also common to provide to other scholars the base data so that they can replicate your findings. Replicated findings are an important part of economics or any scientific endeavor and it's also very important in business that somebody can come along and check your work before a large investment is made doing that. In the upcoming classes, we'll do a little bit more statistical analysis and go back over some sources that we're doing. And there's going to be, this is only one more remaining lecture in the week 1 module. This will have just been posted on 8/26. Thank you. Bye-bye.